Alright, so today is Unit 2, Day 2 with rational functions. Sorry, Unit 4, Day 2. And what we're going to do is we're going to look at converting rational functions between two forms. Okay? This rational form, you can look at it as a ratio, otherwise as a fraction. Okay? So this form is just a function over another function. So it could be f of x over g of x. They chose to use n of x over d of x because they're symbolizing the numerator for n and the denominator for d. Okay? And this is a new function. Now, transformational form is this form that is shown to us that we had practice with on day 1, and basically telling us that the vertical asymptotes are shifted left or right by looking at the denominator, and that the horizontal asymptotes are shifted up and down by looking at that k value. Okay? And that was that transformations that we did last time as far as x, y, method in regards to where is it going and by how much. So we're going to convert transformational to rational form. Now, we've done this way back when we started learning fractions, like in 4th or 5th grade, and we're going to do this example real quick. Yes, question?
Do we have printed notes for this, or are we just talking about it?
We do have printed notes. Let me pass. Okay, so resuming the video, we are looking at converting from transformational to rational form. A way you can interpret that is, I'm converting from a mixed fraction representation, and I'm going to something that we used to do a lot back in the day, to an improper fraction form. Okay? So 5 2/3 is the same as multiplying 3 with 5 to get 15, and then adding 2. And you might have seen some acronym where they might have said in grade school, like it was the Texas method, as far as the state of Texas. Whatever helps you out. But you're multiplying the 3 with 5, then adding 2 to get 17 over thirds, or over 3. This is that rational form, okay? So converting mixed form to a rational form, and that rational form that we remember way back when is the improper form. Yes?
You have a pen?
I do. Okay, so now we're going to do that with functions now. Not just with numbers, but with f of x is equal to transformational forms of the functions. Alright, here we go. So I'm going to look first at my denominator, just like I did over here at 3. And the way I multiplied this 3 with 5, I'm going to multiply this x minus 8 with this number that's sitting all by itself. Okay? So I'm imagining x minus 8 times 2, and then at the very, very end, I'm just going to add to whatever all that is, the numerator. Okay? So distributing this 2x minus 8, what would I get?
2x minus 16.
2x minus 16. And then I'm going to do plus 5, but it's all over my original denominator, just like it was over here. See, I wrote 17 over my original denominator, which was 3. So I'm going to do the same thing here, and my original denominator is x minus 8. Now I just have to simplify, and I'm done. So my final answer will be f of x is equal to negative 16 plus 5 is a negative 11. And again, if you correct me, no worries, I do appreciate it. You get participation points. That would be the rational form of this transformational to rational conversion. Any questions from that first example that we just did? Okay, so let us keep going. I'm going to do the same, and sometimes there's subtle differences between these. I'm going to grab this denominator and multiply it with this negative 2. So over here, negative 2 parentheses. And from experience, guys, these parentheses are huge because people will not remember to distribute the 2 or the negative 2 over everything. And then it's negative 2 times this x minus 5 squared. At the end, we're going to add 3 because remember, you're adding the numerator. and it's all over my original denominator. And now I just have to look at all that, and it is a lot, but I have to simplify it out. Because rational form up here and here, when you simplify everything, has no parentheses. Okay, that's the interpretation that we're going to see as far as when we FOIL everything out, when we simplify everything out, we're not going to have any parentheses. So let's see what we get. Let me make some room over here. If you remember PEMDAS, PEMDAS says we need to do this exponent first to this x minus 5. Just to recap, x minus 5 squared is equivalent not to x squared plus 25 or x squared minus 25. It's equivalent to this thing, since it had a multiplicity of 2, being written out twice. And then you're going to FOIL this out. Okay? So FOILing this out, we get x squared. We get minus 5, and another minus 5 gives us negative 10x. And then finally, the last numbers, negative 5 times negative 5 will give me this. Now remember, we have to distribute this negative 2 across everything. And this is where people forget this parentheses. Bless you. The negative 2 distributed across everything will give us negative 2x squared plus 20 minus 50. And then at the very, very end, we're going to add this 3. Okay? So adding this 3 to this negative 50 will give us a final answer of negative 2x squared plus 20x minus 47. Anybody? What do we do with the denominator?
Put it on the bottom.
We put it on the bottom, but we also have to remember that we need to do what with the final answer? Not subtract. Distribute, right? We have to simplify x minus 5 squared. So x minus 5 squared, we remember from our work before, gave us this part. So that distribution will be x squared minus 10x plus 25. And this is f of x. Now let me ask you. So transformations from before, we did f of x was the original, and g of x was the change, or the changes. Here, even though we're working with transformational form, please don't get confused and change this to g of x. If it starts off as f of x, it's going to still finish as f of x. They're just two different forms. Yes?
Quick question.
Yep.
Can you simplify that or just leave it as normal?
Leave it as normal. So, thank you for that question. A big misconception that people think is that they can start canceling different things right here. Is that allowable, yes or no? It's not. The only way that you can cancel between pieces in a fraction is if what exists as an operation between those pieces? Multiplication. Okay? So if multiplication exists between pieces, for instance, let's look at this. Excellent timing with that question too. X squared times y to the 4th times z to the 3rd. And then down here, let's say I had x, y to the 5th, and then z to the 10th. Can I cancel these two, yes or no? I can. And the reason why I can is because between the pieces, all these pieces, multiplication exists. Just like you can chisel off each little piece between multiplicative pieces. Okay? So x squared and x, we know we would be left with one of the x's up top. Who would win for the y's? The bottom by 1. How about the z's? The bottom by what? 7. So this would be a canceled, reduced, simplified form because of cancellation. Please do not think these x squareds cancel here again, because multiplication is not existing between these individual pieces. Okay? Alright. Any other questions? Alright, so let's go to our third and fourth examples. Alright, so convert rational form this time to transformational form. You with me? So just like way back in the day, and this was like maybe 3rd grade, okay, and I remember because I loved my 3rd grade math teacher, 17 divided by 16, or sorry, divided by 6, I know that will fit 2 times to get me 12. What's the remainder? 5. So just like you used to do way back when, 2 with a remainder of 5, you're now going to do it like this. 2 plus the remainder of 5, okay? And this 5 should be 5 over what? 5 over 6. So plus 5 over 6, way back in the day, this is how you would do this. You would say 2 and 5/6. So it's like the backward process of what we just did the last 2 problems. Okay? So when I see this, I'm going to do a little bit of long division, and I'm going to be able to get 4x plus 9 divided by x plus 2. Now I know it's been a while since we've done long division with those polynomials, but it hasn't been that long. I have 2 terms, start right there, right above the 9. And I need to be asking myself right now, what thing could I multiply with this first term to get 4x? And what would it be? 4. So that's the only thing that you have to match up. So you're going to put 4 here, and now it's like 4 times that x plus 2. Don't forget this parentheses, because then you'll get 4x plus 8. And what is the mistake a lot of people make right here?
They combine instead of subtract.
They combine instead of subtract. So I need to subtract this parenthetic piece so that you see it's actually subtracting a positive 4. And then this negative is like distributing with this positive 8 to say that it's subtracting 8. So what's your remainder? Anybody? 1. So if the remainder is 1, you're just going to write it the same way, guys. You're going to put 4 plus remainder 1 over your original divisor, what you were dividing by.
Do we want to put it?
Oh, you could do it that way too. So you could put, I think I know what your question is. You could put it like this, or you might be accustomed, because of the way we did day 1 notes, to put it like this. Either one is acceptable and is correct.
But why in that one do you have like the 2 times 5?
Okay, so very nice question. For the longest time, we know that this is 2 and 5/6.
Yeah.
Okay? This does not mean what Chase just asked. It doesn't mean 2 times 5/6. So believe it or not, in my opinion, these, the way we've been writing since like 4th or 5th grade, we should have been writing like this. A lot of people don't understand it that way. That's why the terminology was here. But the way we're writing it here is actually interpreted like this.
So could you write 4 and 1 x over 2? So just take away the plus sign. You should write like that as well.
No, very good question. He's saying, can you, since we can take away this plus sign and just write it close together, don't do that here, okay? So don't do this. 4 and then 1, that. Because with math, that's saying 4 times that, which would be 4 over 1 times this would give you this. And those are not, those are not the same.
Okay.
Excellent, excellent question. Good timing as well. So this needs to stay there. You want them in 2 terms in transformational form. Anyone, what is the parent function of that? Where did that come from? We were working with those yesterday. Irrational, 1 over x, right? What's the first transformation that you see? And again, most of the time you'll see it in this form right here. What's the first change or transformation? Moved it 2 to the left, and then up 4. Perfect. So the vertical asymptote moved to the left, so it's now x is equal to -2. And the horizontal moved up 4, so it's now at y equals 4. Good, just a little review. Let's go to number 4 down here. Alright, so number 4 has -3x squared plus 24x minus 54. And you're going to divide it all by this. Okay? Now here we go again. Same thing. Long division. I know it can be a little bit annoying. Just got to be very methodical and very neat and precise. I have three terms. So I'm going to start right here. What term will multiply with this first one to get me the first one down here? -3. Okay, and now we're going to distribute that -3 across all of those pieces. So you get -3x squared plus 24x minus 48. We're going to subtract all of this. That means this will become a positive. A negative times a positive will become a negative. And then this negative times this negative will become a positive. So I'm really adding 3x squared to get 0. I'm really subtracting the 24 to get 0. And last but not least, I'm really adding the 48 so that I get a -6 as my final remaining answer. Okay, so with the remainders, we know those are the ones that are going to have this as their denominator. So it's -6 over all of this stuff. And then this is going to be -3. So we have f of x, and this will be on the quiz, guys, for sure. On Friday, this information as far as knowing how to convert back and forth between transformational and rational form.
This is transformational or rational form.
So this right here, we converted it to transformational form.
So the one that we did before is rational?
Yeah, so this was from transformational, we're converting to rational form. Okay?
That's crazy.
So these are rational forms, and these are transformational forms. In a big way you can see the transformational form
So you can graph them.
is that you can graph them, but you also see that horizontal asymptote all over there by himself or herself, and knowing as far as up or down shifting that horizontal asymptote. Okay? Alright. Every time you do this, a kitten dies. Don't kill kittens, please. This is what I was talking about, guys. You can't cancel between additive pieces. Okay? You can only cancel between multiplication. Alright.
Wait, what do you mean by that?
So, let's say, because you see how these two are adding with each other? What if I had this? X plus 2, and then 2y, and then something like z. My question to you is, can I cancel those two, yes or no?
Not yet.
Yes. And the reason why I can is because multiplication exists between the pieces that they're connected to. You understand? So entire pieces you can, if and only if multiplication exists between the pieces. Awesome question. Good timing as well. Let's go to solving rational functions. So I'm going to make all of these, I'm going to factor, and then I'm going to simplify. Okay? So look, these are rational expressions. We know rational means fraction. What do expressions mean, guys? Why the word expression?
It's how they're portrayed.
True, but what are they missing? The equal sign. They don't have something equals what you see. So if there's no equal sign, it's not a function, it's not an equation, it's an expression. Okay? So, when you see a rational form, okay, and all of these for the most part are not with any parentheses, your first go-to, I would say, is to factor everything. Okay? So let's factor the top of number 1. What could I factor out? 4. Okay? And what I have left is x plus 2. I just GCF'd out of 4. Okay? Now, can I GCF on the bottom, yes or no? No, not right now. There's nothing that they have in common, those three terms. So, my first go-to is I can possibly make 3 terms turn into 2 sets of binomials. Okay, so we're going to practice even more with these factoring by hand strategies that we were strengthening last unit, okay? My first 2 terms, right here and here, they will multiply, and this is the order that you should do this, they will multiply to get what? 3x squared. Okay? They will multiply to get 3x squared. So what should I assign these? 3x and x. Good. Now these terms, because there's only 2 in each parentheses, they will multiply to get what number up here that you see? -4. Okay, so you're targeting the first and the last numbers, which represent the first and the last numbers of the expanded polynomial. Okay, here we go. Give me factors of 4. What 2 numbers could multiply to get 4? 2 and 2, but also what? 1 and 4. Now here we go. If it's 1 and 4, now remember that strategy that I told you? If you add them, they could get 4. If you subtract them, they could give you 0. If you add these, you could get 5. But if you subtract them, you would get 3. Now we're looking for this 4 right here. It could possibly be this one. But this strategy works if and only if the very, very first number is what? 1. Nicely done. 1. If it's not, you got to get creative. You got to test and trial and error it. Okay? So from these 2 pairs, there's trial and error. And you're going to see it build together. Which one do you want to try out? 2 and 2 or 1 and 4? 2 and 2. Let's try 2 and 2 only because they're the same. Okay, and you'll see why here in just a bit. If I do 2 and 2, look at this. I get 2 times x is 2. And 3x times 2 is 6. So if I add these together, I could get 8. But if I subtract them, I could get 4. And this 4 is exactly the one that we need in order to make this work. Last but not least, we just have to make sure the signs line up. Okay, here we go. We know that this 2 and this 2 will multiply to get -4. So one of them has to be a positive and one of them has to be a negative. Which one do you think is a positive? Which one do you think is a negative?
X plus 2, 3x minus 2.
So you think it's this? Let's check it out. We know right now -2 times 2 does give us a -4. But we have to make sure, and I'm going to highlight it in blue, we got to make sure we get this +4 from these 2 being added together. So if I have a -2x and a +6x, sure enough I do get a +4x. So these 2 roots are exactly the way you factor it. Nicely done.
And since they're multiplying, can you cancel the x plus 2's?
You can. So our next part is we're going to simplify. And exactly just like Chase said, because they are multiplying right here and here, we can cancel those out. So all you're left with on top is 4, and all you're left with on the bottom, without needing to write parentheses, is 3x minus 2. This is not equal to f of x because this was never established as a function or anything to solve. So just simplifying an expression. Alright. Factoring skills have definitely improved. Let's continue with number 2. Very first step again is factor everything. Can I GCF anything out of the top and bottom? No. So I'm going to go straight to 2 sets of parentheses since I have 3 terms. And now here's my approach. I'm going to show you again. These first 2 will multiply to get x squared. What should they be? X and x. These last 2 will multiply to get -14. We have a lot of choices. Well, not a lot. We have 2 and 7 or 1 and 14. Okay? Let me show you. Because of the fact that this is a 1, just like you said on that last problem, we can use this strategy to quickly see which one we should use. If I add, we get 15. If I subtract, we get 13. If I add here, we get 9. If I subtract, we get 5. We are wanting this -5 right here. So it has to be 2 and 7. Okay, so let's put these 2 and 7. Last thing we just have to work out are the signs. That's it. You know? So 2 and 7 being multiplied will give us negative 14. So what do y'all think I should put? X plus 2 and x minus 7. Perfect. Positive 2 times negative 7 is negative 14. And here we go. Positive 2, negative 7 does give us a negative 5. That's exactly how you factor. And guys, it's like that over and over. We're going to do a lot of factoring in this unit, okay? So with that, let's kind of jump ahead a little bit. What are my first two terms for the denominator? X and x. Which one do you think our last two terms should be? 2 and 6. What do you think my signs should be? Both positive. And at the very end, you can check it by saying positive 2x and then a positive 6x. They do give us 8. And last but not least, a positive 2 and a positive 6 multiplied, they give us a positive 12. Nicely done. Now, what should I do to simplify? Cancel out the x plus 2's. So x minus 7 over x plus 6 is your reduced final expression. Alright. Alright, so this one's a little bit of a doozy. You can see, man, these are not going to be that easy. They're going to be a little bit more involved because of the fact that that number is not 1. But the same approach every single time. I think you should do this approach instead of quadratic formula, because quadratic formula takes too much time. Alright, first step, what should I do? What should I look for first step? GCF. Do you see a GCF anywhere? No. Okay, so here we go. We are going to concentrate on this first term. This is where your number sense comes into play. Those of you who can do a lot in your head, it does help. What should I put? 10x and x? Or should I put 5x and 2x? What do you think we should try out first, just to see how it plays out?
5x and 2x.
5 and 2x. Let's try the 5x and 2x. I always agree that you should get the ones that are closer to the center than the further out of that factoring rainbow that I showed you that one time. Alright, so now, what two numbers should we use there? We can use 1 and 10 or 2 and 5 again.
1 and
1
10.
and 10? Okay, so if we use 1 and 10, where do you want the 1 and where do you want the 10 to go?
I want the 10 next to the 5.
Right here?
And then the 1 next to the 2.
Okay. Now, and this may or may not work. We're going to see and develop the awareness of how we change stuff. How about the signs? What should the signs be? We know we want a positive 21. You see what I'm saying? So if I have a positive here, that'll get me 20. Since this was negative, I know I have to have this as a negative because how else am I going to get negative 10? You see what I'm saying? How else am I going to get these to multiply to get this negative 10?
It's going to be 5 and 2.
But it's going to be a positive 20 and it's going to be a negative 5, which will give us a positive 15. So that one didn't work. No worries. We can back that up just a little bit. And instead of 10 and 1, we have a choice. We can either change to 5 and 2, or we could put 1 here and put 10 over here. You with me? With the 1 and 10 switching, do you think that'll work?
No.
It won't, because look, you have 2 and you have 50. 2 and 50 will either get us 52 or 48. That's nowhere close to the 21 that we need. Okay? So we know, off of that, we have to go back and do 5 and 2. Alright, so where do you think the 5 should go? We're trial and erroring this.
It's going to go next to the 2x, and the 2 is going to be 5x.
Perfect. So where do we go with, how about the signs? Where are the signs going to be?
Negative for the 2 and positive for the 5.
Perfect. And this is how we can check it out. Negative 4x,
Yeah, that's it.
and then a positive 25 will give us, because remember those are adding that positive 21. And then last but not least, we know this negative 2, this negative 2 multiplied with the positive 5 will give us the negative 10. Hey guys, once you factor 1, you can kind of use it as a cheating example, if you will, to see, well, maybe this would be 2x plus 5, and I don't know what this is, but we'll figure it out. You see what I'm saying? So, or vice versa. We could say maybe the first one was 5x minus 2. These are kind of giving hints of what the bottom pieces could be, because just like these other pieces, they did, in fact, cancel. Okay? So here we go. What do you think my first two terms should be at the bottom?
5 and
5
5.
and 5. So 5x, 5x and 5x. And you're starting to get better and faster with this. Good. What should my last two numbers be? 2 and 2? Okay. So we'll say 2, and we'll say 2. What should my signs be?
Negative and negative.
Negative and negative. Let's see if it works. Alright, so the first terms will multiply to get 25x squared. That works. The last terms will multiply to get a positive 4. That works. And last but not least, a negative 10x and another negative 10x will add to get me negative 20. So this, in fact, did work. Now let me ask you this. Since these are the same, can this cancel both of
No,
these?
we can only cancel
You
one.
can only cancel one, yeah. Only one. So you're left with 2x plus 5, 5x minus 2. The simplified, reduced expression form. Any questions? Okay. So this last part, guys, we have 6 questions to do. And we should probably stop here at this point. I'll give you time to work on your homework for today. Okay. This is combining all the skills you've been learning and reviewing up until now. Okay. So don't let this become overwhelming. It can be if you're not careful, but just watch the strategy. Here we go. This right here is saying simplify, so we have to reduce. And we are going to reduce the rational expressions. And the reason why we are calling this a rational expression, even though it has these equal signs, is it wasn't set equal to something else. It wasn't set equal to 0 or y or anything like that. Okay? Alright, here we go. When you see something in this form, what did we say up until now that you should probably do right at the very beginning?
Factor.
Factor everything. Okay? So here we go. X minus 3, x plus 5, 2x minus 6, and now this trinomial, I'm going to factor. Okay? Now, what are my two terms? Because you're getting better, a lot better at this. What are my two terms? X and x. What are my last two terms, do you think? 4 and 5. And what are my signs in the middle?
Positive.
Positive and positive. You guys are killing it. You're doing awesome. Awesome. Yes? The 2x minus 6. Oh, you mean GCF. You're right. You're right. You could GCF the 2x minus 6. Nicely done. To Sydney, what would we do? Perfect. Now look. All of these have multiplicative pieces. There's multiplication here, 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 and that's pretty much it. I mean, technically there are multiplication forms in between the fractions, like top and bottom, but what I want you to interpret is the top is one entire thing in parentheses, but you don't need to write them in parentheses. Okay, but they're interpreted as being in parentheses. So now this says I can cancel this and this, and I can cancel this and this. Guys, why can I do that? They weren't on top of the same fraction. Why can I do that?
Multiplication.
Multiplication glues it all together. So it's one huge fraction.
So what would be on top?
So what's left on top is just 1, an understood 1.
And then the 2 would go before the x plus 4.
Perfect. Yep. 2x plus 4. 1's left up top. And remember, we got to simplify our answer. So no parentheses in your final answer. So your final answer on this one is going to be 2x plus 8. Because you're just distributing this. Okay? So let's go ahead and write that out. 1 over 2x plus 8. That's it.
This is what's going to be on the quiz.
This is the last stuff that's going to be on the quiz. Now the adding and or multiplying and dividing, that's actually easier with fractions. But when we get to the adding and subtraction, I want to make sure that you have enough sound skills as far as factoring goes, okay? Here we go. I have a division between fractions right now. What should I do?
Flip the one of the terms upside down and have a multiplication.
Okay, yeah, so which one do y'all want to flip?
The x plus 3 over 4, that one.
So it's actually this one, okay? So you keep, change, flip. So you're going to keep the first one, and then you're going to change this to multiplication, and then you're going to flip x squared plus 4x plus 3 all over x minus 7. Now I just said it. It's actually the second one. Does it matter? It actually does. Because order matters with what? Division. 1 divided by 3 is not the same as 3 divided by 1. Order matters with division and order matters with subtraction. Order does not matter with addition and multiplication. Yes? So now, what's our next step?
Factor.
Factor the top. Factor the top right piece. So we're going to...
X plus 1 and x plus 3.
Yes, x plus 1 and x plus 3. And you're starting to see it a lot faster. If you don't, please get my attention. Okay? Yes or no? Can I cancel those two pieces?
Yes.
Yes. Okay? Because of multiplication. Are there any other pieces I can cancel? No.
So you can distribute the 4 to the x plus 1.
Perfect. So now I'm going to distribute what's left over as 4x plus 4. And then what's left over of x minus 7, and you're done. Please, 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 do not look at your final answer and be like, okay, I can cancel those x's. So it'll be 8 over negative 7. You can't do that because these are not multiplication pieces. Okay? So that's your final reduced expression form. Okay. 4 more problems, we're done for today. And I'll let you work on your homework. When you are adding or subtracting, it's different. It's not as easy as canceling a bunch of stuff. What you're actually going to try to do is get common denominators before you combine stuff. Okay, here we go. The bottom right needs to be factored. Can anyone help me out with that? Yep, perfect. This is x plus 2, x minus 2. Because 3 words, it's a what? Difference of squares. Perfect.
Don't you have to multiply negative 2 on the other side so you can have a common denominator?
Yeah, we're about to get our common denominator here in just a bit. But right now, what we've done so far is perfect. Factored. We've set it up. Just like Chase is saying, we need a common denominator. We need all of this denominator to be the same as all of this denominator. You with me? What's it missing right now? X minus 2. So we're going to multiply by a form of 1, because anything times 1 is still the same thing. But now I have the same, because parentheses are here, the same denominators. You with me? So at the very, very end, you're going to be able to combine these two together into one huge x plus 2 and x minus 2 being that common denominator. Now we just got to work with our numerator pieces by simplifying them and distributing, and then put it all together here at the end right here. Alright, distributing this, what do I get?
2x squared minus 4.
2x squared, I didn't hear the rest, what was?
Minus 4.
Minus 4x.
Yeah.
Okay, and now watch, here's where mistakes can happen, okay? You're going to add all of this. If it was subtracting, it'd be different. But because you're going to add, it's basically saying you're going to have a positive sign in front of all of this x minus 11 business. You with me? And guys, if we distribute this, we know that it's just going to stay as plus x minus 11. So we'll put plus x minus 11, and now we're about to combine like terms. Okay, so combining like terms gives us, so these take a while, they take a little bit of process. We get 2x squared minus 3x minus 11, x plus 2, x minus 2. Notice that I didn't distribute the bottom yet. And the reason why I didn't distribute the bottom is because I'm going to see, could I use those factors so that they will end up canceling out like these did, like these did, like x plus 3, x plus 3 did. Go with me? Okay. Here we go. I know it's been a while, but this is the best way that I think you should do it. I think you should look at the coefficients of the thing that you're trying to see. Is it factorable by any one of these zeros over here? Okay? And like we did way back when with synthetic division, we had 2, negative 3, and negative 11. You got really good at this. Now watch. I'm going to try this factor out right here first. Let me highlight it in yellow. I want to try this factor out. So you tell me, if I'm trying this out, what number should I write there?
Negative 2.
Negative 2. Nice. Nice, awesome memory. Negative 2. Okay? So copy. What gets written? Negative 4, and then negative 7 because you're adding. And then
Positive 14.
positive 14. Will this get me 0?
No.
No. So we know this is not a factor, that it's going to be able to cancel like that with. Okay? So let's go back and try the other one that it says x minus 2. Okay? So now if we're trying this, what is the number that goes here?
Positive 2.
Positive 2. There we go. What do I write? 2, 4, 1, 2. That's not going to go to 0. And whenever you see that, guys, you can go straight and just distribute everything on the bottom. No parentheses. Be done with it by doing this. Here we go. X squared. And then you have a negative and a positive 2, which goes to 0. This is a difference of squares. And then a negative 4. So the denominator becomes back to that difference of squares that we had originally way back here. And you get 2x squared minus 3x minus 11. And this is your most simplified form with no parentheses for that adding of two fractions.
Does that mean that's impossible? Like if you start with like the even number and it ends with like the negative 11 and odd number, wouldn't it be impossible to have no remainder?
Oh, look at you, man. We got a lot of points to give out today. He's saying, instead of trying to do all this, could you just do the rational root there? Remember to start it from the bottom, now we're here? So, started from the bottom would give me 1 and 2, the factors of that first number. The last number were 11. So it's just 1 and 11. Those are the only factors. So I could have 1 over 1. I could have 1 over 2. I could have 11 over 1. Or I could have 11 over 2. So 1, 1 half, 11, and 11 halves. None of those are a negative 2 or a positive 2. And that's even faster. Nicely done, man. Even faster to see, will it be factorable? Okay? Alright, let's go to number 7. Ran out of room. So this one is another subtraction of fractions. First step, what do? Not keep change flip on this, only we do keep change flip with dividing ones, but for subtraction, we don't want to do keep change flip.
So we factor.
So we factor first, because we're trying to then get a common denominator. Okay? So here we go. X plus 6 over 2 parentheses minus 2x plus 4. And I'm going to remember that where Sydney helped us last time. The 2x plus 4 is the GCF. Help me out, guys. What are my first two terms over here on the bottom left? X and X. X plus 4 and X plus 3. We've gotten really fast, and your number sense is built very well, okay? Now, I know that I need common denominators to subtract these. They're not very common right now. I have this, and I have this. What does the first fraction need that it doesn't have that the other one has? 2. So we're going to multiply by a form of 1. 2 over 2. Now it has the 2. What does the second one need?
X plus 3.
But we need to do it on top and bottom, right? Because it's a form of 1. So it'll be x plus 3 over x plus 3. Okay? I'm glad you guys talked me into doing these videos too, because this can get daunting. And you can do a lot of practice with this and studying at home than 1 or 2 problems in equal time, okay? So this is good practice. Alright, here we go. I'm going to combine all of this to one huge fraction that has 2x plus 4 and x plus 3 only written how many times? Once. Now we just have to simplify all this, subtracting, simplify all that. Okay, here we go. We're going to distribute the 2 so that we get 2x plus 12. Okay? Now, be careful here, because some people will do a negative 5 times this, and some people will do the 5 first and say that distributing would give me 5x plus 15, and then they take care of this negative. To me, that's the way I did it in high school. And it worked easier for me because I didn't miss any of them. So it'd get negative 5x minus 15. But some of you can see it's just a negative 5 distributed with x plus 3. And if I distribute it, we still get the same thing. Negative 5x minus 15. Whatever floats your boat. Oh, thank you. Whatever floats your boat, use whatever you'd like to. But whatever one that you make less errors with, obviously is the one that I want you to use. So negative 5x minus 15. Okay? Let's see what combines together. We have negative 5, we have 2. So we'll get negative 3x. The 12 and the negative 15 is a negative 3. And now it's all over 2x plus 4, x plus 3. Do y'all see anything that I can do right now?
GCF on the top.
Yes, I can GCF on the top. What could I GCF?
Negative 3.
Negative 3. So if I pull out a negative 3, I'm left with anybody?
X plus 1.
X plus 1. Okay? So I GCF'd from the top to get this, and I'm going to write that so you can see, do any of these pieces reduce afterwards? So negative 3x plus 1. Does anything like cancel out like this? Yes or no? No. And because it doesn't anywhere, we're going to distribute everything and write the final answer. So we get negative 3x minus 3. You're probably thinking to yourself, why did we just go right back to that? Because we did this to see could we cancel at the very end. And then you're going to get x squared. 3 and 4 gives us 7x. And then 4 and 3 gives us 12. Which we will then distribute the 2 across everything. Because remember PEMDAS order to give us 14x at the end, 24 And this is our simplified rational expression form. Nicely done. Very, very nicely done. 2 more problems, and if you need to copy it later, please refer to the video and just finish copying it later. But I want you to watch this in action, which is another big reason why I like this idea of recording the days, okay? All right. Now, solving. We're not going to simplify anymore. We're going to solve for x. Now, there's 2 ways we could do this. If you've been following and you've been acquiring all these skills, the shortcut that I give you is the fastest and most efficient way, okay? If not, you might have to do more work, but you'll still get to the same answer. What do you suggest? From what y'all know, you tell me, what should I try out first to solve for x? And this is 1 over x plus 13 over 3 is equal to 7 over x. What would you do?
Find a common denominator.
Find a common denominator. What's the common denominator? 3x. The least common denominator is 3x. And you guys are going straight to the shortcut that I was going to show you. I'm going to multiply everything by this. Okay? So 3x is going to multiply everything. All these terms are going to be distributed with 3x. Here we go. We are multiplying right now, guys. What is 3x? When I multiply 3x with 1 over x, what are going to cancel? The x's. Because remember, this is 3x over what? 1. So the x's will cancel, and whatever's left, when we cancel everything else, what are you left with? 3. So these x's cancel. Okay, so let me write that so you can see it. That x will cancel with the x to get 1. And now multiply everything across 3 and 1 to get 3. 1 and an understood 1 from that cancellation will give us 3. So this distribution just gave us 3. When we do the second distribution, what cancels?
3.
The 3. What is left over?
13x.
13x. Because you distributed that 13. When I distribute the last one, what cancels? The x. What's left over? 21. The 3 times the 7. Now look at this, guys. With the LCD, I have no fractions, and this is like algebra 1 all over again. Okay? So I'm going to subtract 3, and you get 18. And then my final answer, anybody, is what? 18 over 13. Now, one last thing. This was a fancy word back earlier whenever you were doing solving for things that look like this. It's called extraneous solutions. What does that extraneous solutions mean? Do you remember? It means when the answers don't work. It means you get answers, but if you plug them in back into the original equation, it doesn't work. You get like dividing by 0 of undefined pieces and stuff. Could I plug this back in for x and be safe? Yes or no?
No.
And I won't be safe? How? I actually will be safe. Like, what I'm saying is, if I plug this in where x is, does it make the denominator 0 anywhere? It doesn't. There's nothing that makes the denominator 0, and I'll show you those here in just a bit. So this one is safe. At 18 over 13 is an answer. It's not extraneous. It works. Okay? Let's do the last one. I have 1, 2, 3 terms. You guys went straight to it. So I'm going to take off where you took me. What's the LCD? What's the least common denominator?
X plus 2.
X plus 2. So I'm going to multiply everything by x plus 2. Let's multiply this first one. What cancels, guys? The x plus 2's. The x plus 2's, right? The entire x plus 2. Let me show this. I'm multiplying everything by x plus 2.
So you're left with 1?
So you're left with 1. So when you multiply all that, we said we knew it was over and understood 1. This cancels, and you're left with just 1 times x, which is what? X. Now let's multiply x plus 2. Okay, let me highlight it in orange. X plus 2 is not going to multiply with this. What does that give me?
X squared plus 2x.
X squared plus 2x. Okay, so x plus 2 multiplied with x distributed gives me x squared plus 2x. Okay, I'm going to put parentheses right here and here because sometimes this sign will actually be a what? A negative. And if it is, you need to remember when you distribute it across this guy, it does change that sign. Okay? Alright. Last but not least, when I distribute across this last piece, what cancels? The x plus 2 is what's left? 5x plus 8. This is as difficult as these get, by the way. And if you're doing well, guys, you're going to do very well on this test as well. Because y'all did awesome on this last test. But I'm going to give you back here in just a bit. Alright, so let's combine everything together. What do I do? You tell me.
Distribute the positive first.
Distribute the positive.
Combine like terms.
Okay, so here we go. Combining like terms. What am I going to do with this specific problem?
X
You're
squared
gonna add
plus
that
2.
x with 2x.
Yep, I'm going to have x squareds all on the left, and I am going to add my x's together. So here we go. On the left right now I have 3x. And I'm going to subtract over 5x.
To be negative 2x.
It would be minus 2x. Should I move the 8? Yes or no? I actually should.
So because you can then create like
So
the
it's
x.
0.
You can create 2 zeros. with
Yeah, exactly. So here's the thing, guys. If you ever have an a term and a b term, that means you have an x squared with a coefficient, which in this case is 1. You have an x with a coefficient, which in this case is negative 2. If you have an a and a b term, both, you need to move everything to the left side and set it equal to 0. Always. Okay?
Now, do you want us to factor that? Or
Yeah. And now we're going to factor this to 2 binomials.
X minus 4 and x plus 2.
X minus 4 and x plus 2. So that means x is equal to
Negative 2.
negative 2 and positive 4. Now, here we go. These are answers that we got. Algebraically, we got these answers. This is the last problem. Does negative 2 work if I were to plug it in everywhere where I saw an x in the original? No.
Because it makes it 0.
It makes it 0 for those two denominators, and that's when it gets undefined. How about 4?
4 is fine.
4 is fine. So on your test quiz, for the unit quiz on Friday, you would show that with an X because you're saying it's extraneous. Awesome, awesome job today.